Good afternoon. This is the SkillCourt Rebounding Sports Training Structure. I am John Conley.
I'm Erim Gokce.
Jonathan Perez.
I'm John Lewis.
And we'll begin. So, SkillCourt aims to provide professional-grade training to sports enthusiasts of every skill level. We, as a team, specifically intend to design, manufacture, and calibrate a rebounding structure for outdoor use. We also intend to integrate the use of infrared LED sensors to track the player movement in order to keep the frame normal to the player at all times. We intend to facilitate the training of fundamental soccer skills in order to play soccer at a competitive level. We intend to do that by manufacturing a product which has an adjustable angle impact, as well as be collapsible and portable for ease of transport. One of our largest, one of the biggest goals we're trying to achieve is the tracking, or the tracking of the struck ball on the frame. So determining which quadrant is hit on the frame. In order to do so, we have performed literature survey for four sensors, namely a load cell, piezo-resistive sensor, a tension sensor. But due to geometrical constraints, we are not going to pursue a load cell or the piezo-resistive sensor. We look further into the tension sensor and a mechanical toggle switch. As you can see, these tension sensors would be inline. They allow output configuration and they do meet our geometrical constraint, but they have a low range of force sensing, and they do not meet our budget. So we did not pursue this tension sensor. We are currently investigating further the mechanical toggle switch in order to determine what side of the frame is struck. To track the player, we intend on using infrared LED sensors to track the player's position in relation to the frame, and then have the frame autonomously move in relation to the player as they are training with our frame. We have the tentative goal of determining ball velocity when the ball is struck on the frame.
These are related standards that we'll be employing by the end of this project. These sub-bullet points contain the actual standards. For the metallic frame itself, we decided to go with aluminum 6061, and as the gentleman suggested, consider coating to provide extra corrosion resistance. The rebounding mesh will be using EPDM rubber cordage. The assembly will employ various screws and fasteners, and all of the CAD modeling will be done with English imperial units. The energy source, one of them will be using photovoltaic panels. Some of our objectives are frame targeting. The frame must have a target on it for the player to aim for. Also, the frame must track the player so it can adjust itself according to how the player moves. We also desire to have a rebound rate of 90% of the original momentum, and we have a large, diverse audience, so we need to have affordability and safety according to different financial situations and ages. The frame must also be collapsible and portable, and we would like to collaborate our code for the frame with the SkillCourt instant feedback code that's already there. Design specifications, I'd already mentioned the 90% coefficient of restitution rate. We would also like the frame to accommodate up to 30-foot distance between the kicker and the frame itself. And to accommodate different financial situations, we have these three different tiers or trim levels, as we call them. The first one will be solar panels and onboard LCD display only. The second will include those plus rechargeable batteries and phone pairing. And the third will include all of the above. So, addressing global design, I had already mentioned the different tier levels for different financial situations across the world. And the product will have to operate in diverse weather conditions all over the world. The solar panels will allow the system to operate in places where there's no electrical output availability. And the instructional videos and manuals that we include will have various languages to accommodate global design. Finally, our constraints. We want the frame to be rectangular in shape to emulate soccer goals that are already existent. The system must work in locations that are far away from electrical output, and it must be weather resistant and accommodate load-bearing materials. Also, we have sensors, so we need to protect those from high sunlight exposure, and we want it to be affordable for customers.
So I'll be going over the designs. We have a couple design alternatives. The first one being a trampoline style rebounder, which we assess to be a high vibration risk in the case if you try to strike it with a soccer ball and then a couple seconds later strike it with another soccer ball. It wouldn't provide us the best feedback that we'd like. So we came up with another alternative. This would be using taut nylon strings, sort of like a tennis racket. Had a high coefficient of restitution and a low vibration risk. The only problem is that we wanted to add this level of autonomy to our design, and it wasn't very feedback friendly. So we came up with our third design alternative, which is sort of the base of our final design. As you can see, it has a nylon shock cord that runs through it, sort of like, again, a tennis racket, and it has wheels that will be electrically controlled by electric motors to provide the level of autonomy. The only thing with this design that we came up with, it was very heavy. It was a little bit hard to provide feedback, so we added into the design the mechanical toggle switches in which the ball would strike the shock cord and displace it enough to move the mechanical switch, which is electrically conductive, and break a circuit, allowing us to know that it has hit that portion of the actual frame for targeting. And then we also hollowed out the inside of the frame to make it much lighter and put slotted dowels all around the sides like a tennis racket, also reducing the weight as well. And yeah, so that was our chosen design. And then here's some stress simulations that we decided to do. For this presentation, we specifically went over the frame where the ball is going to be striking as the most important at this time. On the left, you can see the stress developed on the striking surface. This was mainly done to make sure that the dowels wouldn't break under a high force kick. And then on the right, you can see that the actual cords would deflect enough to be able to move the mechanical toggle switches and break the circuit, letting us know where it would be hit. And here's the simulation for the actual frame itself, because sometimes the player might not actually hit the surface, it'll hit the outskirts of the frame. We wanted to make sure that was mechanically sound as well. So on the left is the stress developed on the frame, you can see they're very low. And on the right, on the right is the stresses, on the left is the actual displacement.
We took a look at this here. We have our cost analysis, a very detailed list of what we'll be needing for our parts in terms of transmitters, the IR receivers, the wheels, shock cords, and everything. We've totaled it up so far to about $273, but as you can see, our aluminum sheets have not been finalized in terms of pricing and our provider, which we will eventually be adding on later on to total up our total price. For the division of team responsibility, John right here, he's our team coordinator, our project manager. John, he will be handling CAD modeling and most of the cost components. I myself will be doing most of the prototyping, construction and testing, and Erim will be handling simulations, calculations, and surveying. Even though we are all head of different departments, we will all be coming together to make sure this project is done to the best of its ability. Our Gantt chart, as you can see, we are well in perspective in terms of times and our presentations and getting all our goals and objectives done within the allotted time until final presentations. And to conclude, we want to believe that we do have the best design for the constraints and the objectives that we are meeting, especially with the Ford design that we're going with. We believe our design specifications that we will be providing will meet with a lot of the global design specifications in terms of is it globally and economically safe and able to be used. We do, however, in terms of our future work, we want to make it less in terms of weight, less heavy still, and reducing the cost, of course, in terms of affordability, and making sure that our program codes are matching with SkillCourt program codes, therefore making sure our product is at 100% efficiency. This is our poster, and I'd like to thank you guys for listening in and open the floor and answer questions.
My question is tied to an off-incidence impact. In other words, I miss the beautiful shock absorbers and I hit the corner of this device, is it designed, or I want to make sure that you design it so that you don't damage the motors that drive the drivers, the solar cells that you've got in the system, that's all been taken into account.
Yes, so actually in the model that we provided, we took away the backing plate that's going to be behind it, so when the switches when the rods are deflected, it doesn't actually, if it's deflected too much and somehow it breaks, it doesn't fly into the actual box and damage any of the components. We just happen to take it off for...
If I hit the corner of this thing, I can flip this piece.
We're hoping not.
Yeah, that's the analysis I want.
In this phase of the project, we've only determined whether the frame itself can withstand a strike. Now, the connection to the base and having the base remain upright, that is the next portion of testing and experimentation. We are currently, that's currently in the works.
But that came into
That's the concern I have.
into play with our challenges in terms of weight, because our initial heavyweight would have been able to withstand that completely fine. It's more so now making it more less weight and portable is where we're gonna have that issue.
So what happens when the sun is really bright?
Better put on some sunglasses and play. Hopefully. I'm hoping it doesn't affect any of our sensors. Our current restriction with using infrared LED emitter and receiver is distance and signal strength. We didn't mention it here, but we're currently looking into using cameras to track color and provide the player with a vest of a particular color and have it track the player and not be affected by sunlight either.
And your photovoltaic cells are just going to handle the fluctuation of current without a problem?
We have not evaluated photovoltaic cells yet. We have to evaluate the electrical system as a whole and determine the power output necessary to run the system for multiple hours and still charged at the same time. Trying to figure out how to work that better. We are currently in the process of evaluating electrical components.
And I'm very concerned about shock.
The connection of the frame to the base is where we intend to mitigate the shock issues. We haven't developed any mechanism yet to dampen the shock in relation to transferring the shock from the frame to the base. That is currently being investigated.
What about water sealing your electronic components?
Everything's going to be sealed watertight. All our electrical components are going to be sealed and isolated in an elevated position to where no moisture is going to get them. Yes, sir.
I have a couple questions on design considerations. First one is, it looks like you have two wheels, right?
It's hard to see underneath the frame, the base. There is a support to keep it on, keep it level.
So is it like stubs, like legs?
Yes, almost.
Yeah.
It's almost like a fixed point that is going to stay in the ground and it's going to rotate along one central pivot. So when the player moves, the wheels alternate and it rotates in a single point.
Okay, so you're gonna have a single point, and this thing is gonna rotate around it.
Yes, it's not moving forward or back to track the player. It's just rotating in place in relation to the player in the field. For professional use, we have the goal of having it be able to track the player up to 30 feet. For other consumers like children, amateurs, anything, they're going to be using the frame to their best ability, but it's not going to fall into the player in any sense of that.
And the angle that you have it is fixed?
It's going to be mechanically...
so you can adjust the
Yeah,
angle?
yeah.
As they get further, the angle goes further back, so to accommodate the rebound back to the player.
And it's going to just be a pin and a slot. So you pull up the pin adjust its angle, put the pin back in, it'll rigidly hold in place. And that's how we're going to do that.
Okay. As far as what you were mentioning before of tracking the player, you might want to search online. There's a drone that you wear a wristband, and it follows you around. It knows exactly where you are, and it takes pictures of you. You might want to see if that is something that you could implement into this, so you don't have to wear a vest. You can just wear a sensor. There's also a GoPro mount that you can wear a sensor, and when it sees you, it rotates the camera to that particular point. So it might be just
The only
easier to look at how they did it, or what kind of, whether it's laser, infrared, or even GPS, and to see if that is better and it resolves your sunlight issue.
The only reason I would say we pursue wearing a vest is this is strictly a training scenario. If you ever watch people train on soccer field, they all have their, they already have vests on specific colors. It's something lightweight that won't interfere the player while they're playing. You break off, you hit something and you break your sensor, the system's faulty. You're wearing an emitter, like an infrared emitter, that's something bulky in the pocket, on your arm, whatever the fact may be. We're trying to minimize player constraint. So that was the goal with tracking color. That was our vision. Any more questions?
Yes. You said your design is going to be able to operate in different terrains and weather conditions. How many different terrains and weather conditions, and which ones? And also, how are you going to test to meet those criteria?
As for terrain, we mean mainly like a flat surface. Anything that's a flat surface, whether it be concrete or grass or turf. That's usually what soccer is either played on, grass, turf, or turf, and it's usually level playing field. Especially for professionals, it has to be a level playing field. If you want to answer.
For our goal, particularly our biggest worry is water. Whether the mechanism will be able to rotate autonomously on wet surface. I feel like if that's just on tire grip, and that's dependent solely on that. Once we determine what type of grip we use, then it should carry over to multiple different frames. And then the coating on the materials, the aluminum, just to reduce corrosion, is the only goals we're going for. The only things we're going to be doing to mitigate those problems.
And you have a plan as far as going about testing, as far as that's concerned?
We have a plethora of professional soccer players at our disposal, and we are going to work them to the bone and just experiment and calibrate as needed.
But we are making a smaller prototype that we should have by the end of this semester. End of this semester, beginning of next semester. We are making a smaller prototype, make sure we can get the electronics to work together, and the actual toggle switch idea, make sure that works correctly as well.
So is this only going to be used in the summer, or can this be used like in the winter, like in a real winter, not South Florida winter?
Like snow?
Yeah.
If the snow is piled up too high to actually play, then no. As long as the conditions of, I guess the weather conditions are suitable for playing or training, then we intend for it to function properly. I have never seen soccer players play in a foot of snow, so those are certain things we're not taking into account.
I agree, but tire compound changes significantly in cold weather, and you may not actually have the movement you expect to have if you can say this is going to work below freezing. So I don't know if that's going to actually affect it or not. I would just consider what your operating range is.
We might just word what we wrote a little differently and try to develop only playing conditions, or we're only going to test along playing conditions.
That's fair. It's just constraining your design is all that matters.
Okay.
Because if you tell me you're going to do everything, you don't do everything, then you didn't do what you told me you're going to do. So.
For your wheels, consider tracks or rails, maybe instead of just, since this is pivoting around a single point, then what if you just have the track already come with it, where it's just moving along that track?
On the bottom?
Yeah, I mean, where you have the wheels, you just encase that, so no matter what surface is underneath it, you'll always have that track below it. You can disregard that different terrain or different weather condition scenario. Second thing, to answer his question about what happens if you can hit the corner, don't wait until you test it. Do a free body diagram, understand what happens if you put that 300-pound force in that corner. Is it going to topple over? These are, I keep repeating myself with the other teams, you need to resolve these issues even before you make it. Try and get as much out of the way before you manufacture this, because if you make it and it turns out that just a light kick, this thing topples over, he's gonna be mad.
Yeah.
And you wanna make sure you fixed it before you test it.
On paper, you can, but no one,
And for the winter, he was mentioning, I would be more concerned on what the rubber on your grid does in low temperatures than I would be about your track. Right? How much is that going to, how much is that rubber stiffening or yielding if you're playing in Saudi Arabia versus you're playing in Alaska in the winter? Understand, as you mentioned, this is usually what we see soccer players play in, from 32 degrees all the way up to 100, and they're designed for that. Choose your materials according to that.
Any other questions?
Thank you.